Page 256 in your Algebra 2 textbook today, we're going to look at completing the square, not the square as in the shape of a square, but a square in reference to a quadratic equation. And so we're going to start using things that are perfect squares to help us factor and then solve quadratics. We're just going to jump on in. I'm at example 1 on page 256, all right? And so kind of the clue in what you're looking for to start this. Now, you can do this with any quadratic, but here's some times that I would use it. If C is a perfect square and the number on the other side is a perfect square, then this is something that can be simple to work with sometimes. Now, it's not so much about the number over here that matters. It's going to be about what is C and can we make that be a square factor that gets to our middle term, all right? And so normally what we do right here is we'd minus 36 and go and maybe try to factor it or graph it. But I want to show you something different, okay? If you will notice right now, on the left side of this equation, I can break down, all right, 9. And when I look at factors of 9 to get 6, I've got 1 times 9, I've got 3 times 3. 3 and 3 is 6, okay? So we make reference to that. I mean, that's the same factor. It's a square factor, okay? 9 is a perfect square. So when I go write out the factors, I get the same thing. X squared plus 6x plus 9 breaks down to x plus 3 times x plus 3. Those are square factors. So I can rewrite this as just one factor of x plus 3 squared equals 36, and that's the point today. If I can factor this side and get it to where it's the same factor times itself, I can write it like this. Now, the reason this is nice is because I now am allowed to take the square root of both sides, and it's an easy way to solve. All right? So right here, I'm just going and following my steps to get x by itself. I need to get rid of the exponent of 2, so I'm going to take the square root of the left, and I'm going to take the square root on the right to get rid of our squared over there, or our exponent of 2. Now, the square root of x plus 3 squared is just x plus 3. That cleans up really nice for us. On this side, what you have to understand that I'm dealing with is plus or minus the square root of 36 or whatever's there. Now, that won't always be a perfect square. It is here, okay? But you have to understand when I take the square root of that quadratic on the left side, I now have 2 answers on the right side, a plus or minus. So I'm going to clean this up a little bit. That's x plus 3 equals plus or minus 6. You're like, well, what do I do with it, okay? I'm going to go ahead and move and get x by itself. So I've got x equals negative 3 plus or minus 6. So there are my 2 answers. I just need to split them up. Now you're like, how'd you know it was 2? Remember, this x squared right here tells us we're expecting 2x answers. Okay, it's quadratic. We're expecting 2 of them. So what I'm going to end up doing is splitting this up. One of my answers is negative 3 plus 6, and one of my answers is negative 3 minus 6. You just split up that plus or minus sign again. That's a 3 right there. Okay? You just split it up, and now do the math. Okay? Negative 3 plus 6 is positive 3. And negative 3 minus 6 is negative 9. There are your 2 answers. Okay? Those would be your 2 x-intercepts. All right? So it's pretty simple to go deal with this. And kind of what we're looking for is C a perfect square, and can I write perfect square factors? Again, x plus 3 times x plus 3 is the same thing. So you kind of see how it goes. Now let's pick it up and make one work to our advantage. Let's go to example 2 at the top of page 257. Let's see how this plays out. So I got example 2, and it says this. It says x squared minus 10x plus 25 equals 27. Okay? Now 27 is not a perfect square, but 25 is, and I'm going to see if I've got factors of 25 that can get negative 10. Now remember, if you struggle with this, go on the calculator, do y equals 25 divided by x. Since I'm trying to get to negative 10 in the middle, I know that I got to have negative signs. Negative 1 times negative 25. Negative 5 times negative 5. There we go. There's my 2. 25 is a perfect square. It's got factors, all right? So I'm going to write it out. That's x minus 5 times x minus 5, and that still equals 27. Look at that. I've got the same factor happening, so I'm going to rewrite it. X minus 5 squared equals 27. Square root of both sides. So x minus 5 equals plus or minus radical 27. Now remember how we break that down. That's not a perfect square. So I need to go now and do y equals 27 divided by x and look for the biggest perfect square factor. Okay, so you start looking at the table, and you'd have 1 and 27. we get to 3 and 9. That'd be your giveaway right there, okay? 3 is prime. That's not always how it works, but it works here. 9 is a perfect square, so I'm going to break down 27 as 9 times 3, and we're taking the square root of those. So this side, so I've got x minus 5 equals 3 plus or minus the square root of 3. Oh, I screwed that up. Put the 3 here. Plus or minus, 3 radical 3. Don't put that 3 in front. Okay, so I took the square root of 9. I took the square root of 3, which I can't do, and it cleans up to plus or minus 3 radical 3. Now, I add 5 to both sides. The 5 is what's going in front, and I get x equals 5 plus or minus 3 radical 3. Okay? I can't combine these. They're not like terms. This would have to have a square root of 3 on it. It doesn't. I can just write my answer like that. You need to know this is 2 answers. 5 plus 3 radical 3, 5 minus 3 radical 3. Now, in ALEKS or on ConnectEd, it's very conceivable that they could ask you to find that number. Well, in your calculator, do 5 plus 3 radical 3. You can see in the book, it's about 10.2. You can do 5 minus 3 radical 3, and you get negative 0.2. So that's definitely some stuff that you can put in a calculator real quick and get a decimal value, if that's what they're asking for. Okay, now here's how we can make these squares work for us. All right, so I am jumping to example 4. All right, we're going to complete the square. X squared plus 10x minus 11 equals 0. It says to complete the square. So you've seen in the last couple of examples of if C was a perfect square, I could kind of make the problem work in my favor. We're going to do that here by making our own C. That's a perfect square, but we got a little formula we're going to follow. All right, so here are your first steps, and this really is completing the square. The first thing I'm going to do is I'm going to move C if it's there. So I'm going to rewrite this. X squared plus 10x. Leave yourself some space. Put a blank there. I'm going to move negative 11 over, so it's going to become positive 11, and I'm also going to put my blank right there. All right? So here's how we're going to get the number that goes in this blank. Here's a little formula for you. You're going to take B, you're going to divide it by 2, and you're going to square it. Now, if you look on the front page of all the work that we just did, that's a B, not a 6. If you look on the front page of the work that we just did, it's what happens every time. If you'd have taken B, divided it by 2, and squared it, you'd have gotten that C term. So we're going to do it right here. B divided by 2 squared. So here's how I'm going to write it. I'm going to write my factor already as something squared, just like we did on the front side. I'm going to go ahead and get it there. It's what I want. It's called a perfect square trinomial. All right? So I'm going to take B. I'm going to divide it by 2. So B is positive 10. So I'm going to take it and divide by 2. That's positive 5. Then I'm going to square that. 5 squared is positive 25, and I'm going to come plug it in right here. And if I do it on the left side of the equal sign, I have to add the same thing on the right side of the equal sign. Now notice, I moved 11 over here, and it was positive 11. I'm just going to leave it as 11 over there. I didn't need to put that plus 11 there. We know that it's positive 11. Okay? So what I've got here, and again, see it, B divided by 2. 10 divided by 2 is 5. 5 squared is positive 25. Put it in both blanks. That's why I like putting the blanks there, so you know to put in the same thing to balance the equation. Now, on the right side of the equation, we do the math. What's 11 plus 25? Well, it's 36. It's kind of nice that that's going to end up being a perfect square, but this step right here is just what we did on the front page. We wrote our perfect square trinomial. Now we've got it equal to a number. How can we solve this? Now we take the square root of both sides. The square root of x plus 5 squared is x plus 5. I'm going to go and do this in one step. The square root of 36 is plus or minus 6, right? Now I need to minus 5 from both sides. Now when I do this, it's x equals, and I'm going to go ahead and do negative 5 plus or minus 6. I'm going to write it that way just to kind of keep it split since it's plus or minus, and then I'm going to split it up. X equals negative 5 plus 6. X equals negative 5 minus 6. Pretty simple. Negative 5 plus 6 is 1. Negative 5 minus 6 is negative 11. There's your 2 roots. Okay? All right, Coach, could we graph these? Yes, but we need to understand this concept. This is something that's going to help us further along. Now, I'm going to come back in class, and I'm going to show you probably another one of these completing the square, and I'm going to show you what to do when A is greater than 1. It's a little bit tricky, but it's something that I think I can show you in class and that we'll end up getting. If you'll notice down here in example 6, this is also something you can do with imaginaries. So as you kind of seen that in 4-4, imaginaries are going to play in, and we're going to kind of keep looking at all this. There's a good chance that I end up splitting this up and show you some examples of this again on YouTube so that you can kind of see what's going on. Appreciate your attention. And I try to remind you of this all the time. You're always welcome to to come get help. Anytime during this, you can stop the recording, come ask. You can ask, watch it all, and come ask. Please come get help if you're needing help. Thank you.